Okay, let's start. Hello everyone, this is the past competition element working group session. So today we have a tight agenda. So Harry will take care of the minutes, but feel free to help him on the CodeMid. That's the new tool that is used for the IETF meetings to gather everyone on the minute taking. You need a data tracker account to log in, but feel free to use yours and to give a hand to Harry. So they're not well. Everyone should be familiar with them, but we still need to make sure that everyone has get some time to remind themselves. Everything you say, write, share here is subject to IETF IPR policy. Okay, so this is the second day of this IETF meeting. I hope you're all familiar with the way Metico is working, but in case you don't, please be aware that there is a virtual queue to get to the mic. This is the button with the hand on the Metico interface. So use that one to get into the queue, knowing that the other one is supposed to be direct audio, and Travel myself may stop you in case you don't respect this protocol during the meeting itself. As usual, the meeting is recorded, so please remind your name. Even if using Meteco, it's easier to see who's on the queue. It's good to have it also recording in the audio. And considering the tight agenda we have, please try to stick to your time slot when presenting. So the link towards the CodeMid is available in the slides. A quick reminder about the use of the mailing list. This is the IETF preferred tool to share about technical topics, about internal drafts, about the work the working group are handling. Every open issues and conclusions should be shared on the list. The discussions itself also as much as possible to make sure that everyone is involved or can take part into them if applicable. We'd like also to see the new draft introduced to the working group using the mailing list before the meeting slots are requested. People are sometimes eager to read drafts before preparing the meeting. So this is very useful. On the chair needs also to see the feedback from the working group on the mailing list to be able to judge on the consensus on draft on the decision. So we remind you that slots will be given in priority to drafts that have been actively discussed on the mailing list. Also reminder about the working group process, especially during adoption calls on working group last calls. Try to send your feedback at those key times about document life within the IETF. The chairs also need that to make sure there's consensus on the draft at every key step. Try to share your concerns, support as much as possible, knowing that every working group archive can be looked at some point by some other entities at the IETF head. And we obviously don't want to get into appeals processes and so on. So make sure that everything you want to share is reflected on the mailing list. That's a guarantee for further step in the life of the work. Also try to review ideas from others and consider that we are a community working as a group on a working group as a whole. The wiki. We've been using the wiki for quite some time now. This is a very useful tool that allows easy updates to track all the documents that we have within the working group at various stages. It's available even between the meetings, so this is clearly the place where you want to look at if you want to know what is the document maturity on what is the next steps for a given document. And if you've submitted an innovation or achieved a milestone and so on, you may be also interested in updating the wiki page. The link is right here, so feel free to use it and get involved into the wiki of the PC working group. About early cut point allocation, we remind you that in the IETF, there is a process to get early cut point. If you have implementations that need to work together and you want to avoid modifying too much what is implemented, it may be relevant to consider early cut point allocation. The process is not that complex. As soon as there is specification stable enough on the consensus into requesting those early allocation, there is an easy way to get it. So if you really are involved into implementations and interworking, keep that in mind as much as possible. So here we reach the agenda. Does anyone want to bash the agenda? We already have an overflow slot, so we'll see if we can reach it. So let's go into the working group status. We have 11 RFCs in IETF 106. Okay, that's 2 IETF far away, but that's quite a figure. So let me thank again all the chairs that have helped to achieve those, John, Drev, and Adrian. Because this is a collective work that have been achieved there. And we had a long list of backlog in the working group. So this is a significant step to achieve these 11 publications. Also, we thank the authors, the Shepherd, and every reviewers or ADs. It is an ETF usual process, and there are many people involved in the background, including IANA, ERG, RFC editor, and so on. We have one document in the RFC editor queue. I think it get out of 48 today, so the association diversity is progressing well. We have two drafts with the ISG, the scheduling, which has open discusses with the ISG, but HUMO is working on resolving them, so this will be fixed in the near future. And we have the flow spec ID, which faced recent revision due to the the parallel work that happened about the layer 2 flow specification in the BGP flow spec. There is an associated registry for BGP about layer 2, and we wanted to bring consistency within the PCEP flow spec. So there is a new extension that has been added into the draft. Draft published, I think it was last week, a new revision. We'd be happy to get the working group feedback on this change. It doesn't modify the core specification of the draft, but there is a new option supported there to bring alignment with BGP. So feedback from everyone interested would be very welcome using the mailing list as usual. There is also an existing early cut point allocation about the association policy and is supposed to expire in May next year. Beyond the working group There are some existing erratas. Several of them have been already progressed. We have agreement on the way we should address them. So here it's mainly a matter of process between the chairs and the AD to make sure that we properly resolve those and bring the correct status on those errata that have been submitted. There are liaisons with the ITUT study group 15, one that has been replied by Scott Manfield in January, and there is an open one that I've received on last February. So if you have on the list as usual. So, Drav, you want to take the hand from there?
Just 1 second. Let me just share. Okay. Hi, everyone. So I'll quickly go over the status of some of our key working group documents. So this is our working group last call queue. This is mainly for the notification for the working group to know that now is the last chance for you guys to review. The order of our working group last queue would be, we will be doing the PCC document first. It has been stable for a while, mainly editorial changes. There was one INA request that was found to be missing, so which has been added in the latest version. The core specification is quite stable, so we would be moving this document to the working group last queue next. After this, we have association policy. This one had the new implementation details added, and also we had the early code point allocation for this one. So again, this is moving quite well. So this would be our next in our working group last call queue. And finally, we have bidirection association. One clarification was added with PLSP ID usage and the B flag in SRP object in the latest version. It was aligned with the SR bidirectional, which is also on the agenda today. So this would be the next one that we will take up as our working group last call. One document which is nearing working group last call, which is our PCEP Yang document. The T dependencies are moving quite well in the T's working group. We have a dependency also with the netconf document called TLS client server, which was stuck for a while, but in this meeting, and I've discussed with the netconf chair as well, that it's moving. They have an order, they have some dependency that they are getting out first. So 3 sets of document working group last call is already going on, and next would be TLS client server, etc. So as this is moving in netconf working group, we could also start moving PCEP Yang after the first 3 documents that we saw. We did an early Yang doctor review for this, so we were thinking maybe it's a time we should get a final Yang doctor review again and focusing on the changes that were made in the early version. And now there were some comments on the mailing list as well, which were handled in the latest version. So this is for your knowledge. If you have any comments on this, please reach in the mailing list. Some of the other working group documents, we have the stateful GMPLS, which was a merged document. The key blocking point here is the implementation status is missing. And if you remember our implementation policy, we need the implementation status section, or at least a discussion about it. You can find our policy on the wiki page. So until that gets handled, we will wait for progressing this. There were changes in the next document, which is the native IP. The native IP document in T's is moving along. So this is the PC extension for it. There were some technical changes in the latest version. Some new fields, some encodings were changed. So please look out for these changes as well. The other document, we have enhanced error. The changes were mainly editorial, and otherwise the document has been quite stable. The flex grid document, mainly editorial changes again, but it has not been discussed for some time in the working group, so authors could consider uh, uh, doing the next step for this. The document where we had some discussion and changes was the PCEP extension for SRv6. This document added one key clarification, especially since PCEP uses the term LSP. We have LSP object, so it clarified that in the context of SRv6, the LSP refers to SRv6 path, and this would be applicable for any future SRv6 work within PCEP as well. There was some cleaning up with fields in SRv6 ERO, SRv6 RRO. So if you guys care about this work, please use our mailing list and provide comments on these documents. We have binding SID. There were comments on the mailing list regarding the length field, which was discussed, and an update was made to handle that. So that was the main change with the binding SID. With VN association, which was adopted around IETF 105, main changes have been editorial, and same is the case for SR path segment as well. These two documents are the recent working group documents that were adopted. The SR bidirectional is actually on the agenda, so we will discuss this document on that slot as well. In fact, Rakesh is presenting this next. And recently, we adopted the SR policy association document as well, so which has not been updated since adoption. So finally, for working group adoption queue, as per our wiki, you could see the next two documents which are in our adoption queue is the PCCC SR and the stateful interdomain document. There are also a list of documents of all where the authors have requested us requested us, and we will get them in one by one order. So you can always look at our wiki for this information. And this is my last slide, and we have Loa in the queue. Oh, Loa, do you want to speak? Because you were sharing the screen instead of the microphone. If you want to speak, click on the microphone link. Right now, you are giving me a request for screen share. Perfect. Loa, go ahead. Loa, can you speak? We are facing some difficulty. So Loa, could you put it in the Jabber if your question, and we can get to it. Here, the audio doesn't seem to be working. Are there any other questions for any working group status or any other documents that anybody would like to talk about? Okay, so then let's move on to the next document in our agenda, which is SR bidirectional. So Rakesh, would you like to join the queue? Yes,
Hi,
Rakesh.
everyone. You guys hear me?
Yes.
Hi, everyone. This is Rakesh Gandhi from Cisco Systems, presenting the draft on the bidirectional SR paths on behalf of the authors listed. Next slide, please. So an agenda is requirement and scope that will look at the new association type for the bidirectional SR path, the PCEP object definitions. So as Drew mentioned, this draft was adopted as a working group document after the last IETF. We received some pretty good comments from Andrew and Adrian, and there was good discussions on the mailing list, and the draft has been updated, and we're presenting the updates for this draft. So next slide, please. So it is the bidirectional SR path in packet transport networks, co-routed or non-co-routed paths. The scope is the associated path. It could be PCE initiated or PCC initiated, stateless PCE as well. Not in the scope is the associating an SR path with an RSVPTE LSP. Next slide, please. So a new association type is defined. It's a slightly different model than the two association types that we have for RSVPT LSP. If you recall, for RSVPT LSP, there is single-sided bidirectional LSP, and there is a double-sided bidirectional LSP. In this particular use case for segment routing paths, it's a double-sided with reverse LSP. Basically, the association happens at a PCE level for the forward and reverse path. So this is an example where both endpoints are given the forward and reverse path for the policy. Next slide, please. And in the PCC case, the PCC gives the information about the forward LSP, and PCE would do the association with the reverse path, and then inform the PCC about reverse path for it. So this is also the PCC initiated supported with this type. Next slide, please. So as mentioned, association type is defined for this particular use case. It's double-sided with the reverse path. Basically, the procedure uses the same as other drafts and RFCs for the association object. Next slide, please. Error handling is also defined in other drafts and RFCs, and it's relevant here as well that LSPs must belong to the same tunnel, or the it can only be part of one bidirectional group, and path setup in this case is SR. So this error also apply in this association group as well. Next slide, please. So we welcome your review and comments and suggestions for all the changes that we made to address lots of good feedback on the mailing list. I think this is my last slide. Any comments, questions?
Hi, Tariq, go ahead.
Hello?
Yeah, go ahead, Tariq.
Oh, hi. This is Tariq with Juniper Networks. Rakesh, does this bidirectional support multiple segment lists, or what would happen if multiple segment lists were in the SR path?
Yeah, so it would be, so this is, as you see, it says SR path, so it doesn't really say, is it a policy or the candidate path or segment list? But yeah, the PCEP has the capability to handle the candidate path and segment list, or when they are added, the corresponding association group will be present in the object to associate them.
So are you disallowing multiple segment lists or an SR candidate path being instantiated with multiple segment lists for bidirectional?
So we are not disallowing it. Not clear what will be the use case, but if there is a use case and if there is a requirement, we can discuss and put relevant text in the draft.
Okay, thank you.
Just to continue on what Tariq was saying, what I would suggest is we have to mention SR policy somewhere in this document, and we have to say that what is the relationship between this work and the SR policy work. So I think we can't leave that question open for interpretation. So it will be good if you handle that.
Definitely, yeah.
I remember there were some other comments as well, so I wanted to make sure that that those comments are handled in this new version. Something which I think got missed was adding PLSP ID in the figures itself, because I think that was one comment where how to make that part a little easier to understand. The idea that we could have multiple PLSP ID associated here. Just go back, and other people who commented during the adoption, please recheck that whether your comments are handled or not. And if you would like to speak, we have some time right here as well.
Yeah, Dhruv, so we will add, yes, I remember now that comment, and yeah, we will add that in the figure.
One more question. Do you think the RSVPT document is ready to ship? Is there any dependency between this work, the SR bidirectional work, and the RSVPT one? Shall we ship RSVPT?
I think so. There was a small change that we had to make in March when we updated this SR path. But since then, 4 months, it's been pretty stable, and there is nothing outstanding. I don't see any intersection at this point.
Okay, thank you. Any other comments from anyone? Okay, so let's move to the next presentation then. Thanks, Rakesh.
Thank you. Thank you.
Mike, could you ask again? Yeah, go ahead, Mike.
Yeah, hi everyone. So this is Mike Koldyshev from Cisco. I'll be presenting PCEP extensions for signaling multipath information on behalf of the authors. Next slide, please. Next slide. Thanks.
It's on introduction right now.
Yeah, thanks. That's good. So in the SR policy architecture, the unit of signaling in both PCEP and BGP is the candidate path. So in BGP, each update may contain multiple segment list sub-TLVs. But in PCEP, we have this limitation of each update or report having only a single ERO object. So this is obviously very limiting for the SR policy use case, because we cannot represent an SR candidate path that has more than one segment list. So in this draft, we propose a way for PCEP, for PCE to basically return multiple paths or multiple EROs within a single report or update. And even though this is meant to solve specifically the SR policy use case, we keep the mechanism generic so that it applies to, it's just a generic way to return multiple paths. It may be applicable to RSVP as well. And it is also applicable to stateless PCEP. So you can do a PC request and you can get a PC reply with a bunch of different, a bunch of ECMP paths. Next slide, please. So we have this kind of motivating example of splitting the bandwidth, where the head end requests 100 gigabits of bandwidth, but all the links have only 60 gigabits. So in this case, the PCE would need to return at least 2 parallel paths in order to meet the 100 gigabits objective. So the PCE has a choice to return. It can return like 2 paths with 50-50 split, or it can return 3 paths with 40-30-30 split, and so on. And the head end doesn't know in advance that it's gonna get, multiple paths. It's up to the PCE to decide that. Next slide, please. So we just introduced this very simple separator object, just so that you can encode multiple EROs or RROs, and you can also carry kind of attributes and some basic information about each ERO or RRO. So today we just have the upper flag, which tells if this particular path is operationally up or down. And we have like a path ID, which is just a numeric identifier for that ERO. In the optional TLVs, we allow to put the weight so that you can have unequal cost multipaths. So you can have like, 60% of traffic on one ERO and 40% on the other ERO and so on. Next slide, please. And we just have this capability negotiation. So it's mandatory in the open object to basically the head end says how many paths it is able to install. And so that's in the open object. And there's also the same TLV can be put in the LSP object to override the number of multipaths per LSP, so that you can say that like for this particular tunnel, I don't want any ECMP, so I just want one segment list or one path. And you would, in that case, you would include this TLV in the LSP object and set the number of multipaths equals to 1. And then the PCE would know that it has to return only one path. Next slide, please. So yeah, so that's it. We would like to request work group adoption and leave some time for Q&A. Thanks.
Any questions? Let me ask some questions by the time other people coming in. There was a discussion on the list still about the use of sub-objects. So I wanted to make sure that within the working group, we have an understanding that we will be using a new object and not use the sub-object technique. So if anybody has any concerns on that, we have some time, we can have a discussion, but it would be a good idea to close on that. So that's one thing that I wanted to ask the working group as well. So feel free to join the queue if you have any thoughts on that. One comment to the authors would be that in the text we still mention SERO, and maybe there is a thought of using this work for P2MP as well. My suggestion would be to leave that out for now. We have the other document, the SR replication P2MP, and maybe it will be better to do that kind of work along with that work and keep this pretty straightforward, focusing on the P2P case. So I wanted to hear from the authors, what do they think about that?
Yeah, point taken. Yeah, we did plan to use it for the tree SID standards to basically kind of program multiple outgoing paths. So we will consider, how to move some of the tree SID specific stuff into the tree SID drafts, so that this one is kind of more, targeted, to a simpler use case.
Thanks, Mike. Any other question? Go ahead, Andrew.
Hi, this is Andrew Stone, Nokia. It's not really a question, it's just a comment on the sub-object versus not the sub-object and that whole discussion that we had on the list. I raised my reply on the list. I think the way that it's structured down in the draft is really the cleanest and tidiest way to do it and follows a lot of the other patterns that were already put in place. So I agree, like personally, I think we can keep it as is, but I don't know if anybody else has any other feedback. That's all I really got. Thanks.
Thanks, Andrew.
Yeah, I agree. I mean, definitely, like the the problem with putting something new in the ERO object is that it's meant to be kind of carrying stuff from RSVPTE, and it's not very so yeah, I think Andrew's reply there on the list kind of summarizes it very well. So
Kwan, go ahead with your question.
I have a question. As we all know, there is a draft that defines the path segment. The path segment is used to identify an SR path, and your draft has defined a path ID. I think is similar. So, what's the difference between the path segment and the path ID?
well, like the path segment is a label, right? That's programmed on the tail end, I believe. So path ID is it's not a label, it's just a numeric value that's unique only within the context of this tunnel. So basically, it would typically have a value like 0, 1, 2. So I think there's no similarity between them. They're kind of very different things. Maybe we can discuss this on the list if you have any concerns.
Okay, thank you.
Mike, I was just going through the document. Even the INA section needs some work because we have some flag fields that we are defining. So make sure that the INA section is also handled. And apart from that, I think the document is in good condition. Thanks for working on it.
Cool, thanks. I'll look at the INA section for sure.
Okay, if there are no more questions, we will move to the next presentation. Kwan, would you like to join the queue so that I can approve? If any of you would like to share video, please feel free. But otherwise, this is fine as well. Go ahead. Go ahead with the presentation.
Okay, I'm Chuan from ZTE. My presentation is PSAP extension for SRMPL's entropy label position. Next slide, please. This draft has been presented in IETF 106, and the comments are appreciated from Stephen, Dhruv, and Tariq. So based on the comments, we made some update. We made some clarification in last in the update from last version. The first one is we made some clarification for the background that the PCE is used to configure the entropy label position. It's because in case of inter-domain scenario, PCE would be useful for computing both SR paths and the position of the entropy labels. Second, we made some clarifications for ingress capability. As defined in RFC 8662, multiple ELI, EL pairs may be inserted in the SRMPL's label stack. So the ingress must support the capability of inserting the pairs, and it needs to be advertised in open message from PCC to PC. So we use the E bit to indicate the capability of inserting multiple ELI, EL pairs at PCC, and at the meantime, it can be used to support the SR path with ELP from PCE. So last slide, please. Let's do the quick recap of the background. The RFC 8662 proposes to apply the entropy labels to SRMPL's networks and provides the criteria to determine the best ELI/EL's placement. So in conclusion, the draft has defined that multiple ELI-EL pairs may be inserted in the SRM-PS label stack. So when the scenario is the SDN and the controller, such as PC, may perform the end-to-end path computation as well as the entropy label position, including the numbers and the place of the ELI-ELs, especially in inter-domain scenarios. So in this version, we updated the scenarios, the inter-domain scenarios as the figure show. For example, the end-to-end SR path is built across two domains from A to Y. There are some ECMP between A and B, C and E, X and J, and K and L. But the ingress A is in domain 1 has no information such as MSD, ERLD of the domain 2. So the procession could be like that. The PC2 computes the SR path and the entropy label position of the domain 2 and send the result to the PC1. And the PC1 will compute the SR path and the ELP information of the domain 1 and send the end-to-end SR path and the ELP to the ingress A. So the ingress A has the end-to-end information, including the SR path and the ELP information. So the label stack with the ELI-EL is like the table shows. It the top one is B and ELI-EL, C, E, and ELI-EL, XJ, ELI-EL. Then the K, Doof. Okay.
Lost. Please give me a second. You can keep speaking.
Okay. So this is the example of the inter-domain scenario. So next slide. So this is the PCEP extensions of this draft. First, we extend the open object in open message. We extend the E bit to indicate it supports the SR path with ELP configuration. Meanwhile, it can be used to indicate the capability of inserting multiple EL pairs at PCC. Second, we extend the LSP object, the black field, and we extend the E black to indicate to compute the SR path with ELP information when the PCC requests the PCE to compute the SR path. Finally, we extend the ERO object. The E bit is used to indicate the position of the indicate the position to insert EL in the SRERO. So next slide, please. So this is all the PCEP extension for the entropy label in SR inter-domain scenarios. So comments and the discussions are very welcome. Thank you.
Thanks, Kwan. Any comments? Please join the queue if you have any comments on this document. Go ahead, Robin.
Can you hear me? Hello?
Yes. Yes, Robin,
Okay.
go ahead.
Okay, Robin from Huawei. So I have a doubt about the solution. So this the ELI or the EL is calculated for SR path or for specific traffic flow? I'm a little confused about this one.
Yeah, we just use the PC to compute the ELI position, not the value of the ELIs, because the EL and the ELIs, the value of the ELIs is computed at the ingress. So we just to propose the PC to compute the placement because the RFC 8662 proposes the criteria to determine the best EL placement. So we think the placement is important and it can be computed in the PC. So PC just compute the placement and the value is computed at the ingress.
I mean, so I understand this is to compute the placement for the ingress, but I mean, so for the ingress, we have the two entity. One entity is the SR path, another is the traffic flow. Maybe identify the 5 tubes. So I wanted to know that when you calculate the position of the ERI or the EL, is this a calculation for the SR path or for the traffic flow identified by the 5 tubes?
I'm not sure, but I think the SR path is also computed for the traffic flow.
I think there's a different granularity. Okay, maybe we can have more discussion in the mailing list. Okay.
Yeah, thanks, Robin.
Okay.
My understanding of reading the draft was that this is being put as a part of SR path. So, especially after reading the document and looking at the encoding, that's what I feel. So maybe you can continue to have this discussion on the list and clarify.
Okay, thank you, Dhruv.
I also sent a mail regarding the last IETF. There was a discussion with Stefan, so we wanted to make sure that we close that discussion. So if anybody else has any thoughts on that, whether just a single bit is enough from PCC's point of view to say that yes, multiple ELI EL pair can be put at PCC. So the current document says that a single bit is enough to show this capability, and we had this discussion in the last meeting whether something more is needed. So I would like for us to have a conclusion on this so we can continue to do that in the mailing list.
Yeah, welcome to discuss in the mailing list.
Okay. Okay. One more question. You have another presentation where we are talking about that in the LSP object, we have run out of flags. So I would suggest you to change this document and use the flags from the extended LSP flag. As you are already aware that there is a problem, we don't have flags available in LSP object. So better to use from extended LSP. So make that change in your document as well.
Okay, thank you.
Any other comments? Okay, let's move to the next presentation. Thank you. Next, we have SRV6 Yang.
Hello.
Hi, Fabrice.
Yeah, hello, Dhruv. Good evening.
Yeah.
Good evening, everyone.
Yeah, if you like to share your video, I can accept. Otherwise, go ahead.
Okay. Just hope my connection is good. Okay.
You can stop anytime if you feel the connection is going back. Go ahead.
Okay. Thank you. I am Luke Fabrice Ndifo from Central African region, precisely Cameroon. I'm working for one of the leading operators in Cameroon. It's MTN in Cameroon, and I'll be presenting to you the young data model for SRv6 support in PSEP on the behalf of my co-authors. It's good to also precise that this is the first time I'm presiding in the IETF meeting. Please, next slide, Drew. Okay, in this slide, we are trying to give some history about the latest developments that we have had on this subject for the PSEP protocol. On the left-hand side, you have the protocol extensions. You have that for the SR-MPLS as defined in the RFC 8664. You have the protocol extension for SRv6, which is an internet draft currently. When we go on the right-hand side, we have the support for the SR-MPLS, which is near working group last call for the which has been added to the basic YAM. And now we are focusing on the draft for SRv6 on the support on YAM. And that was released just July 8th. Next slide, Drew, please. Okay, on this slide, we are trying to provide the added capabilities that we had on the PSEP, amongst which are the capability to compute and convey SRv6 path. We have an added capability, SRv6 PCE capability sub-theory. We also have a new path setup type, a new explicit with object record object for SRv6. We can refer to a draft as well for what was existing for the PSEP protocol for these different elements. Next slide, Joe, please. It is important for us to present to you the basic, that's the added functionality for SR on the basic YAM. We look on the right-hand side. We have the entity, the peer, and also the session, right a bit below. And the SR function capability added at the entity and the peer levels. That was for the added functionality, the capability for the SR on the YAM. So next slide, please, Drew. Okay, now this is what has been done for the SRv6 capability. We have at the entity and the peer levels, where you have an augmented capability for the SRv6. And we also augment the LSP container in the LSP database for the SRv6 parts using the segment list. Next slide, please. Okay, we are requesting more reviews, especially from the implementers and the operators of SRv6, and that this draft is in the PCE work group and is in stable condition, and is a possible candidate for the work group adoption. Thank you. We are open for the Q&As.
Thank you, Fabrice. Any questions? Fabrice, I had not a question directly related to this document, but I was thinking that something that is missing would be for us to link the SID list with the SR policy Yang as well. And this is something which I feel is missing for both SRV6 as well as for SR MPLS. So it would be worth exploring if we could put a reference to the SR policy Yang as well, and not just to the SID list. So that's something that would be worth exploring.
Okay, thank you, Joe. That will be noted. That is noted.
Any other comments from anyone? We do have time. Okay, let's go ahead. Thank you.
Hello, everybody. Can you hear me?
Yes, go ahead.
Yeah, this is the first time that we presented this draft in PC. So we want to extend the ESR policy PCP to enable live feed for next. Yeah, the background and motivation for this work is that we want to combine the iFeed, so in situ flow information telemetry, together with the SR policy. iFeed refers to all the network OM applications that apply data plane and path telemetry techniques. In particular, the most popular are inbound OM and alternate marking. On the other hand, the SR policy is identified through the addend, the color, and the endpoint, and an addend may be in form of candidate path different way through configuration to PC and BGP. In particular, in this draft, we want to define the extension to PCP to distribute XR policies carrying iFeed information. This is the scope. So we are talking about the PCP, and you can look at the relevant draft, adopted draft in the PCP. Next. Yeah, the main change from the 00 version to 02 were caused by some feedback that we got on mailing lists, and also about the companion document in IDR that same thing. The main question about the applicability was clarified, so the extension allows to signal the iFeed capabilities together with the SR policy. In terms of flexibility and dynamicity of the iFeed application, out of scope here, but is in charge, for example, of young module and so on. In any case, for other function and controller and network nodes. Another comment from Drew was about the generalization. This is still under discussion. For now, the current version of the draft states that the iFeed attributes here described can also be generalized for other TLVs, for other association groups. But anyway, the suggestion from Drew was to use the LSPA object. It makes sense to me, since normally association groups are also used not only for SR policy association group, but also for other things that seems not very relevant for telemetry. Anyway, we also reported the data plane documents. In particular, you can see the adopted document for inbound OM and alternate marking, and also the control plane that the draft that I mentioned earlier. So next. Yeah, the main point of the draft is about the SR policy association group that is defined to extend the PCP distribution among candidate paths. The relevant draft that we referenced, there are several TLB already produced, and we want to augment this by introducing the iFeed attribute TLB as a policy association. Next slide, please. So yeah, this is the definition of the different TLV that for people that is familiar with inbound OM, very simple to recognize the relevant information that are considered. So the EOM trace option TLV, the incremental trace option TLV, the direct export, and edge to edge. Next. In this case, we have the SR policy for alternate marking and the enhanced alternate marking TLV. That also in this case, this is referenced from the relevant document in 6 months. Next. Okay, I think that's all. I have 5 minutes time slot. So we want to basically to collect feedbacks. Drew gave some useful input for the generalization. Yeah, okay, in this version, we asked to evaluate working adoption, consider anchor adopted work. Anyway, I think there is some discussion to do on that, in particular because if we want to generalize, we have to consider the relevant data plane that have to support the inbound OM and alternate marking methods. So that is something that should be considered for SR policies. There are already mature work direction, but for other data plane technology, this anyway. Welcome comments and questions.
Tariq, go ahead.
Hey, yeah, hi. This is Tariq from Juniper Networks. My question is about the flow ID. It's coming from the PCE. Is it a global ID or is it scoped within the head end?
Do you mean the flow ID in this draft?
Yes.
In this slide? Yeah. No, this is coming from the draft in 6 months of the alternate marking extension for IPv6, where we define in the option header this flow monitoring identification that is used to identify the flow, monitoring flow.
Okay, so in that draft, there is information about is it global or scoped within the head end?
Yes.
Okay,
Yes.
I'll take a look.
Okay.
Thank you.
Now what?
Loa, go ahead.
Can you hear me now?
Yes.
Yeah.
Okay, so I have a question on flags in the TLVs. Like slide 5, I think was one, or slide 4. Quite supported, but we are kind of used to running out of flag space. Have you any idea on how many flags in a year or two? And if we do, we have to add another flag TLV with 32 flags instead of just adding maybe a couple in the protocol as we have it now. Thanks.
Yes, this is a good point. So we should also evaluate some possible extensibility. But yeah, I understand your point. So you cannot establish how many bits for flags we can use earlier. But anyway, for now, yeah, we made a proposal and we can consider this in the next version.
Okay, thanks.
With some consideration on that.
Giuseppe, one question. Are these flags coming from the data plane documents? So if this point actually makes sense even in the data plane case, as far as I understood that these flags were coming from other documents and they were not defined in PCEP extension, but we are reusing these flags from other documents. Is that correct?
Yeah.
So I think this is a global thing that even IOM folks needs to consider.
Yeah.
Oh, sorry.
Robin, I've added you in the queue. Go ahead.
I think that regarding the issues proposed by the peers, I don't think that the flow ID is a global ID. I think it's I think if it's global, I mean it's also is a domain wide flow ID. I mean that is global in the network domain, and is not is a whole is a that how to say? I mean it's a domain wide flow ID. I mean it's not a global flow ID.
Yeah,
That's my
I mean the
point.
global. I mean the global. Yeah, domain wide. Yeah, global in the domain.
Yeah.
Yeah, in the network domain.
Okay. We are in the same page. Okay.
Yeah.
Thanks, Robin. Any other questions? Okay, let's move to the next. Thanks, Giuseppe.
Okay, thanks.
Andrew, go ahead.
Hi, everybody. This is Andrew Stone from Nokia. Today I'll be presenting local protection enforcement. Next screen, please. So there's been some changes since IETF 106. First is there's 2 new co-authors, so that's good to see. The draft has actually been renamed. It used to be called Path Protection Enforcement. Now it's been renamed Local Protection Enforcement. More accurately reflects exactly what's being protected. There's been added text as well to the actual descriptions to cover different use cases and the comparisons between them. And there have also been implementations added. There are some changes not yet posted. Most of it is just formatting. Dhruv has recently just commented on the list just yesterday, actually, so there will be an update coming for that. Looks like this draft will be updating RFC 5440, and I'll probably be adding a section to comment on PC backwards compatibility. Next slide, please. So just to rehash for those that haven't seen it or missed it, the use case is really to cover 2 situations. One is to influence path computation for expanded use case, and the other one is to improve interoperability. So the expanded use cases are really today in IGP, your adjacency SIDs are advertised with a backup flag associated with it, which will indicate whether or not LFA is available for that segment ID. So using this backup flag, when PC actually goes to choose a path, one, it can influence whether or not that link is part of the path. And as well, there could be a deterministic selection of a SID along a given path. And when it comes to interoperability, this idea of influencing the path calculation and influencing what SID is selected, some vendors have treated as a hard constraint and some have treated it as a soft constraint based off of the previous language in the existing RFCs. So really, we're just trying to cover off the descriptions to make sure that we have better interop in the long term. Next slide, please. So this is really just the diagram trying to highlight the 3 different situations where depending on whether or not you want to have LFA protection on local protection on all hops in your path versus not wanting to have it versus not caring, right? And so in the must have and must not have, you're really influencing the SPF and the actual path that can be found, what feasible paths are available. Whereas in the do not care case, you have a lot more feasible paths, but of course, which shortest path gets chosen and the actual SIDs that are chosen along that path, whether or not they're backup selected or not, will influence the LFA. So I'm not going to really cover all of the different examples. I think you can just kind of look at the diagram a little bit later. But this is basically just showing all the different combinations and what the outcome would be. Next slide, please. So the proposal to really achieve this is just using another bit. So today we've got the L flag for local protection desired, and there's a new flag E bit for enforcement. Between the combination of these 2 bits, it really gives you control over all of the different options. And as well, of course, the document itself talks about different wording and statements on how to actually achieve all of this. Next slide, please. So the implementation status, at the moment, both Nokia and Cisco have implementations on PCC and PCE. If there's anybody else there that has implementations, please let me know. Next slide, please. So the next step that we're hoping to do is, one, hopefully get working group adoption. And along with that, the actual E-flag bit, obviously that needs to be allocated by Anna. So we're hoping to get early code point allocation for that, so that way the implementations may proceed further. And that's all I have. Thank you.
Any questions? Anybody has any thoughts on updating RFC 5440? Is anything related to that? And the usability, of course, please feel free to speak up. Okay, let's go ahead then. Thanks, Andrew.
Cool, thank you. Actually, sorry, just so I assume then I would just send a request to the chairs for the adoption poll?
Yes, and you have to bear with us. There is a bit of a queue here, so we'll get to it.
Sounds good, thank you.
Thank you. Update the implementation section in your document.
Oh, yes,
That would also, yeah.
Yeah,
Thank
no, for
you.
sure. Thanks.
Go ahead, Kwan. Go ahead.
Okay, I'm Tran from the T. My presentation is LSP object flag extension of state for PCE. Next slide, please. This draft has also been presented in IETF 106, and the comments and the consent are appreciated from Dhruv, Chun-Li, Stephen, and Parvin. And this draft has also been discussed in the mailing list and updated according to the suggestion from Dhruv and Adrian Farrell. So based on the suggestion, I first moved this flag extension to an independent draft, and we fixed the text based on the comments as the following show. First, we removed the list of the currently assigned bits, removed the bit 0 in the existing flags field, removed the description of update to RFC 8231, and we added the description of TLV processing, and we define an array of units of 32 bits for the length field. And finally, we ask IANA for new TLV type and a new registry to track the bits in the TLV. So next slide, please. So this is the PSAP extension. First, we extend the LSP object. We because as defined in RFC 8231, the length of LSP object flag field is 12 bits, but the bit 1 to bit 11 has been assigned, shown on the right figure. But many other drafts would like to use the flag. So this draft proposes to define a new LSP extended flag TLV for the LSP object. Like the figure show, we extend the LSP extended flags field. This field contains an array of units of 32-bit flags numbered from the most significant as bit 0, and each bit represents one LSP capability or state. It can be used and occupied by other drafts. Last slide, please. And we also extend the PSAP arrow object. The LSP extended flag TLV must be included in the LSP object when the bits of the extended flag field need to be used. So if the TLV is missing, the PC will generate an arrow with arrow type is 6. It means mandatory object missing, and the arrow value is to be added. It means the LSP extended flag TLV missing, and it must close the session. So last slide. So the PSAP extension is simple, and this is discussed in the mailing list. So we want to get more feedback. And the comments and discussions are very welcome. Thank you.
Any questions? Julian and I were talking about this document. We think that this is something which is useful, and we were considering maybe fast tracking this document. So if folks have any comments, please respond to the list or ask questions here. There is still some tightening up of language that is needed in the document. So I will work with the authors and provide my comments on the list. Any other comments? Okay, let's move to the next one. Shipping, go ahead.
I'm going to introduce the PSAP extensions for PassMTU. Next, please. First, about motivation. And in the traditional MPRS, the PassMTU can be signaled via the protocols like RSVPTE and LDP. However, in the SR networks, there is no signaling to set up the SR pass. And there is currently no support on the negotiation mechanism of the PassMTU. So generally in an SR network, the SR information is reported to the BGP-LS, and the PCE will use those information to calculate the SR pass. And we know that when we start pushing the SAYS, either label or IPv6 addresses into a packet, the packet size is going to be increased. Once the packet size exceeds the PassMTU, the packet will be dropped in IPv6 or fragmented. And from the operators, we learned that when using the least line over multi-domains, the MTU needs to be learned to avoid the packet drops. So this draft, we aim to specify the extensions to PSAP to carry the PassMTU. Next, please. So basically, and this draft defines a new tab for the existing metric object for PassMTU. And the type value needs to be allocated by ANA. And the PassMTU actually goes into the metric value to represent the minimum of the link MTU of all the links along the path. Next, please. Here shows how to use the PassMTU for SR. And the PCE can be used to calculate the SRTE path, considering the various constraints. And now the PassMTU can be used as another metric for PCE to consider while it is calculating the path. Once the path is chosen, and the PCE can inform the PCC the SRTE path together with its PassMTU. And now the SRv6 is supported. So for the new metric type for the PassMTU, that is applicable for the SRTE path, and it doesn't require any additional extensions. Next, please. So we can see that there is a need to convey the path MTU information over the PSAP, and the draft that defines the extensions to BGP to distribute the path MTU information within the SR policy has been progressed, and now it's a working group draft in IDR. And this draft is the corresponding draft for PSAP. So we would like to ask for adoption for this draft. Thank you. That's all. Any questions?
Tariq, go ahead.
Yeah, Tariq from Juniper Networks. The MTU that you're going to signal from the PCE, is it the MPLS MTU, IP MTU, layer 2 MTU? Which MTU is it?
That is depends on the data plane, so it's not limited.
So is it tied up with the LSP? Is that what you're trying to say?
Yes. So LSP could also be, but this is for in the SR network.
Yeah. So if this is SRv6, are you going to signal the IP MTU?
For the IP MTU, what do you mean?
Excluding the L2 header.
This is Robin, Tariq. I mean, hello, can you hear me, Tariq?
Yes. Hi,
yes, Robin.
Okay,
Go ahead.
Okay, yeah. Because I know that because this is for the SR policy. So I mean, the SR policy is the end-to-end path. So I mean, this is the path MTU for the SR policy. But you mean the which MTU is used to calculate the path MTU, because this is report this information maybe through the BGP link state. In the BGP link state, I mean that it can collect the MPLS MTU or some this the IP MTU. But this is if for the SR. For the SR, I mean, if SRv6, I mean, it's definitely IP MTU. But if the SRMPLS, maybe I think this is the choice of the MPLS MTU or the IP MTU. Is depending on the calculation options.
It's good to clarify it, I guess, if it is not already in the draft. I agree, Robin.
Okay. Yeah. Okay.
Thanks, Robin. Chen, go ahead.
It's associated with the data plan. If we are calculating a path MTU for SRv6 path, then this is an IP layer MTU. If we are calculating an SR MPLS path, then it is the MPLS layer MTU. That's it.
Pawan, I've added you. Go ahead. Pawan, go ahead.
Hey, can you guys hear me?
Yes.
Hey, this is Pawan from Juniper. So the path MTU determination, does it take into account, say it's an MPLS path, does it take into account the number of labels in the stack at each hop, or in the case of SRv6 path, does it take the header, incoming header size at each hop of the path, or is it just a conservative estimate, or is it something that is out of the scope of this document?
It considers the for the SRMPLS, it can consider the labels, the label stacks. For the SRv6, it's about the state list.
So is it the, I mean, say say you have 5 hops and you're using adjacency sets, are you just going to discount this label stack size for 5 labels, or is it taking into account what would be the incoming label stack size at each hop? I mean, this is I mean, typically when you're in the case when if you're calculating a path MTU, you do discount for the label stack size or the header size, and then determine what it is. So I mean, I haven't read through the draft, but looking through the slides, you just seem to be saying that it's just the minimum of the link MTU. Do you, or did I get that wrong? I can take it to the list if you know.
Yeah, as far as I see in the document describes as like minimum of the link MTU. But I'll let Cheng and Shupeng answer. You guys have your audio enabled. Go ahead.
Yeah. So first of all, we need to collect the minimum value of the link MTU alongside the pass. But based on this, we need to minus some like overhead of, for example, TIFA overhead. So I suppose that the pass MTU value would be the final value, which is the minimal link MTU minus the other overhead, such as the fast reduced overhead, something like this. So when the PCC, the egress PCC get the pass MTU, then it will be used for use it as the real MTU. Yep.
I think it would result in a conservative estimate, but yeah, I can send something to the list. Yeah.
Yeah, sure.
Yeah.
Any other comments? Okay, thank you. We have one more comment. So go ahead.
Here, when you say talk about path MTU and stuff like that, right? So like here, we're going to consider the repair paths MTU as well, or so just the primary path?
This is currently it's not in the draft, so we could look at it in the future.
Okay, yeah, thanks.
Can you just say for the audio as well? Jagan Babu, can you say your name and affiliation as well?
Hey, I'm Jagan Babu. I'm working for Cisco.
Thanks. Go ahead.
Good. I'm finished.
Okay. Thank you. So since we have time, let's have our final presentation. Go ahead.
Can you hear me? Yes.
Yes.
Can you hear me? Good.
Yes.
So finally, we got a chance to present for many times. So today I'm going to talk about extension for PCE for SR pass ingress protection. So next page. So basically, we have PCE for SR policy. So in this case, the information for SR pass, such as seed list, will send to the primary ingress nodes of SR pass. So in order to provide protection for the failure of the ingress node of P2P pass, we need the information to be sent from a controller PCE to the backup ingress node. So this information will be include the seeds for the backup pass from the backup ingress node to the egress node. In addition, we also need the information for protections. For example, what ingress node we're going to protect by the backup ingress nodes. We need this information. And then, so what kind of traffic will be transported by the SR primary pass? So this information will also be included. Sometimes we also have service information, such as service label or service ID in the package. So this information will also be included in the information to be sent from the controller PCE to the backup ingress node. Next page. So basically, that's the information will be included in this extension. So we need a capability negotiation, and then we need a protection information to be included in the backup path. So this information include primary ingress node information, and the traffic information, and the surface information. So because this one, we already have several versions, but we don't have a chance to present. So during this process, we also get comments from people, and then they think those downstream node information is not needed, so we remove it from this current version. So next page. Yeah, I think that's all for my presentation today. I think we would like to have comments.
Any questions from anyone? Go ahead, Robin.
Can you clarify this? The ingress protection is the local protection or the end-to-end protection?
Yeah, good question. So this is end-to-end protection. Here we require the controller such as PCE to compute an end-to-end path from a backup ingress node to the egress node. And then also we should have some kind of requirement for this path. For example, this path may have minimum intersection with the primary path, and then we have the protection information to be sent to the backup ingress
node. I'm a little confused. If the failure of the PE1 happens, I mean, even there's no PCE to synchronize the backup information. CE1 also can directly can steer the traffic to the backup the SR path. I'm not sure why the information should be synchronized between two PEs.
Yes, that's a good question. Yes. So there's some details there. For example, in order to implement or achieve this protection, so we need some kind of behavior in the CE. For example, CE we may have different behaviors on the CE. So one kind of behavior is that CE1 can multicast the traffic to both ingress node and backup ingress nodes. That's one behavior. So another behavior is that CE1 can detect the failure of PE1 only after detecting the failure of PE1, and then PE1 to CE1 will send traffic to backup egress node. So we have different behaviors there. So for this kind of different behaviors, and then this can be those information delivered to the backup ingress node can help. For example, so in case for the behavior CE1 send the traffic to both ingress node and backup ingress nodes. So in this case, so the controller should notify the backup ingress node. But even so, backup ingress node receives traffic from CE1. So in this case, if primary ingress node is active, and then we just drop that package. So the controller should have delivered this information to the backup ingress node. So for another behavior, so if CE1 only delivers traffic to backup ingress node after the primary ingress fails. So in this case, so the backup ingress node just behavior as normal. As long as there's traffic from CE1, and then we deliver the traffic along the backup ingress along the backup path to the egress node. So that's we need some kind of control information to be delivered to the backup ingress node for protection of the primary ingress node.
Okay.
Are there any more questions? Thank you. That was our last presentation. Julian, any last thoughts? Deborah, anything before we end the session? Julian? Just checking with you. Okay. Thanks, everyone. Thanks for attending PC session. Enjoy your rest of the week. And hope to see you guys in person sometime soon. Stay safe. Thank you.
Thank you.